A political candidate is trying to determine whether his approval rating has suffered due to a questionable comment captured on camera while he thought no one was looking. Before the unfortunate remark, his approval rating was 0.38. After the remark, a random sample of 200 constituents was taken, and 62 said they would vote for him. Test at a 0.01 level of significance to see if his approval rating has suffered. So this is a test about a proportion. In order to justify the use of the normal distribution, we must show that NP and N times 1 minus P are both at least 10. Since our sample size is 200 and our hypothesized proportion is 0.38, then that product, N times 0.38, will be 76. 1 minus P will be 0.62. And therefore, N times 1 minus P will be 200 times 0.62, which will be 124. So we have justified the use of the normal distribution. So let's draw our curve. And right here in the center would be our hypothesized proportion, 0.38. Now the question is, has his approval rating suffered? Which means, is it less than 0.38? So we don't care about any of this up here to the right. If the sample proportion were greater than 0.38, then we wouldn't even be conducting the hypothesis test. The question is it significantly less than 0.38 so that it lands down here in the rejection region where it is very unlikely that we would find our sample proportion if the population proportion is 0.38. So we would need a critical z-value, which we could get from StatCrunch or a table or the TI-84 calculator. If we use the TI-84 calculator to find the critical z-value, we'll do that by pushing second variables distribution. And what we want is the inverse normal distribution, so we'll click 3. The area is 0.01. That's alpha, and it is all concentrated in the left tail. So what we're finding now will be a z-value associated with that spot where 0.01 or 1% of the area has accumulated. We'll leave the mean at 0 and the standard deviation at 1. And then we'll cursor down to paste and hit enter. And this is the syntax that we would have if we were using an earlier version of the TI-83 or 84 that doesn't have that menu-driven inverse normal function, but rather just brings up the inverse normal function with the open parenthesis. The order would be the area, the accumulated area, the mean, and then the standard deviation. Close your parenthesis and hit enter. And we get this value here of minus 2.326 if we round to 3 decimal places. If we were to use StatCrunch, we would push stat, calculators, normal. We'd leave the mean at 0, the standard deviation at 1. We'd put 0.01, our alpha level, here in the box that contains the proportion. We'd leave this at less than or equal to because we need the z-value that accumulates 0.01 to the left. So we'll click compute, and you see from the picture that's what we have. We've accumulated 1% of the entire distribution up to this z-value of minus 2.326 if we round to 3 decimal places. So our critical z-value will be minus 2.326. Now we haven't yet defined our hypotheses. Our null hypothesis, our assumption, is that the population proportion is 0.38. Our alternative hypothesis, what we are testing, is that the population proportion is less than 0.38. And that is consistent with this left tail test picture that we have here. If we were to write out a decision rule, we would say if our z-test value is less than minus 2.326, we should reject the null hypothesis. we can calculate our z-test value using the formula p hat minus our hypothesized proportion divided by big square root hypothesized proportion times 1 minus the hypothesized proportion divided by the number of observations. And so we would have 62 over 200 minus 0.38 divided by square root of 0.38 times 0.62, 1 minus 0.38, divided by 200, the number of observations. And this value is going to come out to minus 2.040 if we round to 3 decimal places, as we did with the critical value. We can find this z-test value using the TI-83 or 84 calculator. We would push stat, go over to tests. This will be a 1 proportion z-test, so 5. So push 5. We have to tell it what our hypothesized proportion is, which this time is 0.38. We need to tell it what our x value is, and that's the number of successes, which this time was 62. Then the number of observations was 200. Make sure that we get the direction of the alternative hypothesis inequality correct so that the p-value that it gives us will be correct. And then come down and hit calculate. And we see that our z-value is minus 2.040 if we round to 3 decimal places. And our p-value is 0.0207. Now looking at this test value, we see that we landed here to the right of minus 2.326, not less than minus 2.326. So our decision would be, do not reject the null hypothesis. We would say something like, sufficient evidence was not gathered at the 0.01 level of significance to conclude that the approval rating has suffered. Now, why would this candidate test this at a 0.01 level of significance? Why would alpha be 0.01 when so many times before alpha has been 0.05? Well, let's take a look at the p-value. We can find the p-value by pushing stat, proportion stats, 1 sample, with summary. The number of successes was 62. The number of observations, 200. Our hypothesized proportion was 0.38. And our alternative hypothesis should say less than, since it's a one-tailed test to the left. Click compute, and we find again our z-stat value that we found earlier, minus 2.040, and we see that our p-value is 0.0207. We notice that this value is greater than 0.01, which is equal to alpha. And so, in other words, the p-value is greater than alpha in this case, and it would lead us to the same conclusion that we should not reject the null hypothesis. But if this test were done at the 0.05 level of significance, then we would have rejected the null hypothesis and concluded that the approval rating has suffered. Now, if this candidate is out trying to drum up contributions for his campaign, he needs to be able to show that his approval rating has not suffered and that he is a viable candidate. So using the 0.01 level of significance, the conclusion was not drawn that his approval rating had suffered.